Hello everyone, welcome to the channel Top Gate. In this video, I will discuss the preemptive priority scheduling algorithm. So in the previous video, we have already seen what is a priority scheduling algorithm, and we have already seen the example of the non-preemptive priority scheduling algorithm. Now in this one, we will discuss about the preemptive version of the priority scheduling algorithm. So let's straight away go to the example. So in this one, we have 5 processes P1 to P5, and for those processes, we have been given the arrival times and the burst times and the priority. So in the previous lecture I have told you that in this priority scheduling algorithm, we will be given with one more component that is called as the priority. So priority will be attached to every process. Clear? So in this one we have these process, and it will be told to us in advance that which number is the highest and which number is the lowest. Okay, so let's suppose that in this one 1 is the highest. So I'll write it here that 1 is the highest priority. Clear? So 1 is the highest and 4 is the lowest one. So let's quickly draw the Gantt chart first, and then I'll try to find out the turnaround time and the waiting time. Clear? So currently we are at time 0, and I'll see that at time 0, is there any process which is arriving in the RAM? Yes, P1 is there, that is arriving on the RAM at time 0. So at time 0, I don't have any other option. I only have this P1. However, the priority of P1 is 3. So if we analyze this one, we can see that P2 is having 1, which is the highest priority. So the first process which needs to run is the process P2, but its arrival time is 1. That is, it is not there in the RAM yet. So we don't have any option. We have only one option right now, that is P1. So at time 0, we have to schedule P1. So P1 will start, and it will try for how many units? It will try for 3 units. Fine. So it will start, and as soon as it reaches point 1, as soon as it reaches time 1, we can see that P2 has arrived. Clear? So now P2 has arrived, and P2's priority is 1, which is more than P1. So at this point, P1 has to stop. Why? Because P1's priority is 3 and P2's priority is 1. So P2's priority is higher than P1. So therefore, irrespective of the remaining time of P1, irrespective of the arrival time of P1, the P1 has to stop here and P2 will continue. So P1 will stop at 1, and it has completed its 1 unit. So how many left? So I'll write 2 here. Okay, so P1 has done 1, and now P2 will take over the CPU, and since P2's priority is the highest among these processes, so therefore P2 will not be able to be preempted. So no process will be able to preempt P2. So P2 will take over the CPU, and it requires burst time of 1. So it will complete its 1 unit at time 2. So P2 has completed, and it will go out of the system. So P2 does not exist in the RAM at all now. So currently we are at time 2. Now I'll see at time 2, is there any process which is there in the RAM? So yes, at time 2 we have P3 also. Clear? So currently in the RAM we have P3, and we have P1 who is again waiting because it has executed 1 unit, and this P3 has 2 units still left, and both the priorities 3, 3 are same in this case. Clear? So we have already seen that in case of a tie, that is, if we have 2 processes who are having the same priority, then in that case we will use the FCFS algorithm. That is, the tiebreaker is the FCFS algorithm. That is, whichever process is coming first, that has to be scheduled first. So at this point, instead of running P3, we will run P1. Why? Because it is having the priority as the same as P3, but it is coming early, it is coming before than P3. So therefore, P1 has to be scheduled now. So again, I'll schedule P1, and this P1 will, since its requirement is 2, so it will start at 2, and as soon as it reaches 3, you can see P4 arrives, but P4's priority is lesser than P1. Therefore, P4 will not be able to preempt P1. Therefore, P1 will continue, and it will reach on to point 4, time 4, and at time 4 it will complete its work, and it will go out of the RAM, and it is terminated. Clear? So P1 has executed 1 unit here and 2 units here. Clear? So now we are at time 4. At time 4, I can see that P5 has also arrived. Clear? And P5's priority is 2. So currently in the RAM we have only 3 processes, P3, P4 and P5. Out of these, the highest priority is of P5. So obviously, since P5's priority is highest, therefore P5 will take over the CPU now, and since its priority is the highest, therefore P5 will complete its whole 5 units. So it will start at 4 and it will complete its work at 9. It will also terminate and goes out of the RAM. Clear? So now in the RAM we have 2 processes, P3 and P4, out of which P3 is having the highest priority. Therefore P3 will start and it requires 2 time units. So it will start at 9, complete its work at 11. So this will also complete and goes out of the system. Now the last process, the only process left in the RAM is P4, and P4's burst time is 1. So it will start at 11, complete its work at 12. So this will also terminate and goes out of the system. So this is the Gantt chart for this preemptive priority scheduling algorithm. And now let's quickly calculate the turnaround time and the wait time. So the completion times for the process are P1, it is running in 2 iterations, this one and this one. So second iteration, finally it is completing at 4. So I will write 4 here. For P2, it is completing its work at 2. P3, it is completing its work at 11. P4, it is completing its work at 12, and P5, it is completing its work at 9. Okay, so now the turnaround time, we know it can be calculated using completion time and the arrival time. So I'll quickly write the completion time: 4, 2, 11, 12, 9, put the minus signs, and the arrival times. Arrival times are 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. That will give you 4 minus 0 is equal to 4, 2 minus 1 is equal to 1, 11 minus 2 is equal to 9, 12 minus 3 is equal to 9, 9 minus 4 is equal to 5. Now the wait time is the turnaround time minus the burst time. So I'll write this turnaround time first: 4, 1, 9, 9, 5. Then put the minus signs and the burst times. Burst times are 3, 1, 2, 1, 5. So 3, 1, 2, 1, 5. That will give you 1, 0, 7, 8, 0. Clear? So let's quickly calculate the average wait time. So the average wait time will be, it is 1078. That is 1 plus 0 plus 7 plus 8 plus 0 divided by, we have 5 process. So 7 plus 1 is 8, 8 plus 8 is 16, 16 by 5. That will give you 3.2. Clear? And the average turnaround time will be, we have this one, 41995. So 4 plus 1 plus 9 plus 9 plus 5 divided by 5. So that will give you 4 plus 1 is 5, 5 plus 5 is 10, and this is 18. So 28 divided by 5, that will give you, it is 5.6. Clear? So 5.6 is your average turnaround time and 3.2 is your average waiting time. Thank you so much.